Okay, so here we are talking about this thing called average rate of change. By the way, from your algebra education, you should know that rate of change means slope. Slope. So when we see average rate of change, you can also think average slope, and a lot of times it'll be abbreviated ROC, rate of change. Well, this is going to be one of the easiest things you ever do in calculus, and it's going to be helped by this monk-like monotone chant. Average rate of change is slope of secant line. One more time. Average rate of change is slope of secant line. If you do that little monk-like monotone chant, what we're going to learn later in this video is going to be super easy. But before we get there, let's make sure we're all on the same page with our terminology. In geometry, a tangent line would touch a circle in only one spot, whereas a secant line would cut through the circle and hit in two spots. All right, so here we are in calculus. Here's some random curvy function. A tangent line hits that function in one exact spot, thus the tangent line, whereas a secant line would cut through that function in two spots. So it's very similar to geometry. And so when you need average rate of change is slope of secant line. All you have to do is find the slope of that secant line. It's that easy. So let's do two quick examples. Let's start with, I'm trying to cover up one of these. All right, let's concentrate on this one. What is the average rate of change of this friendly parabola over this interval? So I took the friendly parabola and I made a basic sketch of it, probably not to scale. And then they said we want the average rate of change from -6 to +2 along the x-axis. So I went ahead and made the actual coordinates there. And if I want to find the average rate of change, literally all I'm doing is finding the slope of this secant line. There's the line that goes through those 2 points. If I can find the slope, I've got the average rate of change, and my eyeballs tell me that slope is negative, so my answer better be negative. Well, I've already done the hard work of plugging in the x values to get out the y value, plugging in the x value to get out the y value. So now I simply say average rate of change is slope of secant line. My Algebra 1 teacher told me slope is y minus y over x minus x. Plug in the y values. Make sure I go in the same order with the x values. Make sure I don't screw up the negatives. And I get a -2, which kind of makes sense in my mind. This is a negatively sloping line. I can't really tell if it's a slope of -2 because the scale's not awesome, but I'm going to believe it. So the average rate of change of this function over that interval, -2. It's that easy. Let's unveil a tougher one. What is the average rate of change of your famous sine of x over the interval from 0 to 5 pi over 2? So it pays to know what sine of x looks like. There's a rough sketch. The secant line would go something like that. Okay, now I know it's hit the sine of x in more than one spot, but I'm really only caring about that spot and that spot. So I look at that and I say my final answer should be rough, should definitely be positive, probably pretty small. Because I understand my sine function, I know that x value has a y value of 1. That's as high as it gets. And that's the origin, that's 0, 0. So average rate of change is slope of secant line. I just need to find the slope of that thing. Y minus y over x minus x. Here it is written in a slightly different form, and it looks like it's going to be ugly, but here's the good thing. I don't have to worry about making this look any fancier or any different. There's nothing wrong with a fraction inside a fraction. So, boom, this is a positive, and it's a 1 divided by, that's approximately a 7 or an 8 if I do the math on that. So it's about a 1/8 slope, positive and pretty small. I would say math checks out. Average rate of change, easiest thing you're ever going to see in calculus, and believe it or not, it will show up on the calculus AP test. Average rate of change of slope of secant line.